Hello, I am the architect Patricio Bonilla from Ecuador, and I am pleased to present the following topic that deals with comparison of the thermal envelope behavior in single-family homes with concrete block masonry made in the city of Gualaceo, Azuay, Ecuador. Introduction. To closely understand the effect on the thermal envelope in single-family homes with concrete block masonry, it is of great interest to establish comparative analyses that show the effect each construction technology has on the level of comfort achieved inside the homes. In July 2022, single-family housing projects represented 83.2% of the total residential buildings. We find that reinforced concrete structure is the predominant materials, in 82.2%. The use of brick in this area has not been accepted for the elaboration of masonry in the construction of single-family homes because of its relative disadvantage in terms of manageability and economy, being a material that requires more investment within construction, so it is replaced by the concrete block. Houses with traditional techniques, made with mud walls, bajarek, adobe blocks, etc., are only found in the historic center of the city of Gualaceo and in some peripheral rural areas of the area. These construction techniques have been lost almost in their entirety due to socioeconomic factors such as migration, the physical effort needed for their development, and above all the introduction of new construction techniques, many of them with a vision of focusing on sustainable construction. There has been no evaluation of the materials, the construction techniques, and above all the maximum and minimum temperatures to which this material is exposed and how this can affect the thermal comfort inside the homes. Add to this the lack of information on the costs generated if adequate treatment is given to the envelopes. The publication carried out in 2022 in the Ingenious magazine by Rodrigo Brito, Daniel Villa, and Esteban Zalamilla, which deals with a comparative analysis of thermal comfort of a single-family home in LSF versus masonry in the city of Cuenca, Azuay, refers to an analysis of the parameters that influence the energy performance of the home. Climatic environment. Ecuador has 6 climatic zones, and Zone 3 is where the city of Gualaceo is located, called continental rainy, in the Andean zone, where its average temperature of 16 degrees Celsius can vary at certain times of the year, with temperatures in 2022, which ranged between 10.5 degrees Celsius up to 22 degrees Celsius. Although temperatures have reached extreme maximums of 3.0 degrees Celsius and 27.8 degrees Celsius, according to data taken by INIAP, this constant climate variation directly affects the thermal behavior in the envelopes. These variations directly influence the thermal envelope of buildings, either due to their location or also due to the material properties used in the different construction systems. Through the analysis and measurement of the climate in the city of Gualaceo, we will be able to make a comparison of the behavior of the thermal envelope in single-family homes, constructions that in a very high percentage are reinforced concrete portico structures, where the traditional masonry is the block of concrete. 7 bedrooms with similar spatial characteristics have been taken as references in each single-family dwelling analyzed by measurements of indoor temperatures, 5 single-family dwellings made with concrete block masonry, 1 single-family dwelling with rammed earth masonry and bajarek, and another of brick masonry. The exterior temperatures of each house were measured simultaneously, using electronic devices for measuring temperature and humidity, with 3 readings in the same day. By means of the comparative method, it will be possible to analyze the behaviors of the thermal envelope. According to the World Health Organization, the comfort temperature for people should be 20 degrees Celsius. Considering that in our analysis we have referred to a specific and very important area such as bedrooms and the effect of material properties on the envelope. Materials and methods. Once the parameters and characteristics that can influence the thermal envelopes have been established through their traditional masonry, and that, based on this, the energy performance within the houses under analysis is obtained, and with this, to be able to determine the level of comfort that exists inside of the same, taking into account the excesses or deficits, which can reach according to their material properties, such as the solar incidence to which they are exposed, and which set parameters of energy performance in each room. BCM, bedroom with concrete block masonry. BBM, bedroom with brick masonry. BTBM, bedroom with tapial and bajarek masonry. Table A. Samples of temperature readings, indoor, outdoor. The room temperature readings, indoor and outdoor, were taken with electronic measuring devices, taking 3 samples, the first at 6 a.m., the second at noon, and the third at 8 p.m., which are detailed in teneming. In contrast, Table 1, Table 2, Table 3, Table 4, Table 5, Table 6, Table 7. Solar incidence. Solar incidence or solar radiation is an important factor for the thermal envelope in buildings, as solar energy is captured through windows or walls to maintain comfortable conditions inside the building. Buildings and minimize the use of expensive and polluting air conditioning systems. Aspects such as the orientation of the building, the morphology, the materials used, as well as the location on the ground are controlled for. In this way, we will be able to better understand the behavior of the thermal envelope of each dwelling analyzed. For this, within this study, the measure that we will adopt will be in WH/M superscript 2, which is the amount of solar energy that 1 square meter of surface receives. Peak solar hour is the energy we receive in watts per M2, and this energy depends on the location and the time of year. Results. To obtain the results by comparing the behavior of the thermal envelope with concrete block masonry, through 3 temperature samples taken in 1 day, in the rooms of our analysis, the solar incidence has also been considered through the modeling and solar study carried out with the Revit software, highlighting that the samples taken were 5 with concrete block masonry construction systems, 1 with brick masonry, and the last one with rammed earth and Baharek masonry. For this, the measurements of each room were taken, determining its area in square meters, its volume in cubic meters, while the temperature is in degrees Celsius. Table 10. With the data referred, by means of a comparative method, we can establish the indoor and outdoor temperature ranges that establish the function of the thermal envelope of each home and, in our case, of each room taken as a sample and in a more specific way, comparing the values taken in comparison with the value that according to the specific norm of thermal comfort required inside rooms. Table 11. The values reached, in hours of higher temperatures, the mud walls showed only an excess of 3.5% with respect to the acceptable thermal comfort, unlike the concrete block that showed an increase of 32.1%. Table 10. Temperature control chart. With the data referred to by the comparative method, we can establish the ranges of interior and exterior temperature that show the function of the thermal envelope of each house and, in our case, each room taken as a sample and, in a more specific way, comparing the values taken in comparison with the matter in terms of thermal comfort required within rooms. In this last graph, it can be seen that, at this time of night, masonry made with concrete block maintains a higher constant with respect to the comfort temperature in relation to the interior and exterior, while brick, mud, and Baharek masonry present differences. Regarding indoor and outdoor temperatures, although with ranges over the comfort temperature, the values reached, in hours of higher temperatures, the mud walls showed only an excess of 3.5% with respect to the acceptable thermal comfort, unlike the concrete block that showed an increase of 32.1%. Discussion. In this last graph, it can be seen that, at this time of night, masonry made with concrete block maintains a higher constant with respect to the comfort temperature in relation to the interior and exterior, while brick, mud, and Baharek masonry present differences. Regarding indoor and outdoor temperatures, although with ranges over the comfort temperature, the values reached, in hours of higher temperatures, the mud walls showed only an excess of 3.5% with respect to the acceptable thermal comfort, unlike the concrete block that showed an increase of 32.1%. Conclusion. During this analysis, through a comparison of the behavior of the thermal envelope in single-family homes with traditional masonry, it has allowed a close observation of the reaction of the envelopes in terms of the weather, shape, orientation, solar incidence, and material properties. The concrete block has become the most used material in this area, but since it is not properly treated, it does not provide stable comfort inside the homes, knowing that temperatures can drop or rise categorically and that they can affect the thermal envelope. Thank you very much for your attention.